This is section 9.4. We're looking at the skills practice. We're going to complete each proportion. Remember, when we have a triangle inside of a triangle, and these lines are parallel, this triangle is going to be similar to the bigger triangle. So if it helps you can write a similarity statement. Obviously the same thing would happen with this pair of triangles as well. We're going to see these diagrams a lot. If they're similar, then you know their corresponding parts correspond or are proportional. So M to B, that's this guy, compared with B to A. So we're comparing the right side of the small triangle to part of the right side of the big triangle. That's going to be the same thing as M to D, that's the bottom of the little triangle, compared with part of the bottom. So we're going to put segment DC there. And number 2, M to R compared with R to S. That's the same thing as M to W compared with W to T. We also did this in the videos before as well. We used lowercase letters, so M to R is lowercase a, R to S is lowercase b. We'll call this lowercase c and lowercase d. A to B equals C to D. You can do it that way too if you don't like this statement. Number 3, segment BD compared with segment AC. These are entire sides. That's the same thing as M to D compared with, watch yourself now, make sure it's the whole entire side of that big triangle, M to C. Number 4, M to B over M to A. So that's the entire right side of the small triangle compared with the entire right side of the big triangle. So we're comparing an entire side to an entire side. What's that equal to? It'll be equal to something over top of the entire bottom of this triangle, M to C. So make sure you're comparing the entire side to an entire side. So it would be segment MD. Number 5, C to D over D to M is the same thing as A to B over B to M. We're just finding the parts that correspond on our pictures. So you can use the marks to help you, you can use the statement to help you. Maybe this proportion AB equals C to D helps you as well. Number 6, M to S, that's this entire side, compared with R to M, that's this entire side, equals M to T, that's an entire side, compared with this entire side, M to W. Okay, so we're just finishing those proportions. The bottom part of this worksheet, we're going to write the proportions that they gave us here and then use cross multiplication to solve for the thing that's missing. So when you have this diagram, triangle inside of a triangle with parallel sides, we know these triangles are similar. We have a side splitter theorem that says that 12 to 8 equals 15 to x. These parts are proportional, is what that says. Now, we're going to cross multiply to solve. We're going to take 15 times 8, and then we're going to divide by 12. That's the quick way to cross multiply. 15 times 8 divided by 12. And that gives you 10. Remember, you can check your answer. 12 to 8, that's the same thing as 3 to 2. Does that equal 15 to 10? That's the same thing as 3 to 2, so it does. So you can always check your work. Number 14, again, same diagram, triangle inside a triangle, you have parallel sides. That means these parts are proportional. This is a great problem to look at. Notice how this 42 is this entire side. So if this whole thing is 42 and this piece is 30, that guy's got to be 12. So you can do this problem exactly how we did this one if you want. You could say that 15 to x equals 30 to 12. What you don't want to do is 15 to x equals 30 to 42. If you're going to mess this problem up, I guarantee you're going to put a 42 there. If you want to put a 42 here, then you have to, that 42 is an entire side of the big triangle. You have to combine the 15 and the x. Okay, so you have options here. You could go with this proportion, or if you wanted to, you could do 30 to 42. 30, that's an entire side. 42, that's an entire side. That's the same thing as this entire side, 15, to this entire side, x plus 15, because we're adding those two. So it's really up to you which one you go with. Just don't do something that's in between these two. Don't make that a 42. Don't make that an x. Okay, let's cross multiply. We're going to do 15 times 12, and we're going to divide by 30. Notice how you get 6. You can check your work. 30 to 12, is that the same thing as 15 to 6? 15 to 6 would be 5 halves. 30 to 12, 6 goes into both, it would be 5 halves as well. Okay, so keep your eyes open for situations where they have that bracket. That's showing you entire sides. Okay, so we'll do this one. 18 is an entire side of the small triangle. That would correspond to the x, because that's an entire side of the big triangle. 36 is an entire side of the small triangle. 50 is an entire side of the big triangle. So this time there was a bracket, but we still used the numbers that we had because these are entire sides. Notice how this guy is not an entire side. That's the difference. Now, you don't need to cross multiply here because I know that 18 goes into 36 twice. 18 times 2 is 36. 25 times 2 is 50. We'll do one more. Let's look at number 16. This is another one of those tricky ones where you got to really be careful with your proportion. You have a triangle inside of a triangle, so these are similar. This 15 and this x, these are entire sides of triangles. So if you're using the 15 and the x, you need to use 25, which is an entire side, and not 15, you need to use 40. Now, if you're not sure where that 40 came from, it's the entire side of this big triangle. It's the bottom of that bigger triangle. Cross multiply. We'll do 15 times 40. And then we're going to divide that by 25. So you get 24. The rest of these follow exactly what we did here. So if you can do these ones, or at least you understand them, you should be okay with those as well.